Right, so I just want to go over the concept that we weren't that clear on today for the hybridization. So the element or the compound we're looking at was a carbon attached to two hydrogens, a double bond, and then another carbon, a double bond. So we talked about the hybridization for this one is an sp2 because it has three electron regions. So I'm going to use red to draw the first bond. And we talk about how the first bond in each region is always a sigma bond. So that's a sigma, and a sigma bond, right? So you have three sigma bonds, and so those are the first three bonds. So those three bonds all have to be at the same energy level, which explains why you need a sp2 hybridization. So it combines three different orbits to allow you to have this space for three different orbits or three different electrons to all bond at the same energy. So that's the sp3 or sp2. And once again, they're all the sigma bonds, right? So for the other carbon molecule, it's an sp because it only has two electron regions. So the second will have two regions. And these are also sigma bonds. So it'll be able to form a bond here, it'll be able to form a bond here. So that's an sp hybridization. And this bond in the middle, this is the first bond, which is the sigma bond. The second bond that's formed is a pi bond, right? So we talk about if you have double or triple bonds, the additional bonds after the first one are all pi bonds. So on this one, what happens is if you look at carbon, right, the total number of orbits it has is 1s and then 3p orbits. So the total is sp3. So what we just used up is the sp2 uses up three of those orbits, and so what's left is an additional p orbit that's if you remember one of the questions we talked about, it's an unmorphed orbit, right? The orbital. So what happens here is the p orbital that's left over gives us room to make the extra bond or the double bond with the other carbon atom, right? So there's an additional bond here. And I'm drawing two of them, but it's really one bond. It's just the two ends of the orbital. And this is the pi bond. Right, so I just want to make sure you understand how it works. So the sigma bond is on the original hybridization of sp2, and then the pi bond is actually using the leftover orbital to make that bond. So that's the overall structure of the two. And then the other idea we were mentioning really briefly was if you make just the sigma bond, that's the first bond in the middle, right? So that's the sigma bond. And when you have this, you're free to kind of rotate about, right? So the two objects on the two sides are kind of able to move freely and rotate in different directions if they wish. But as you can see here in the picture, once you have the two additional bonds on the p orbits, or the pi bonds, so that's going to kind of make the whole structure very rigid. And so at that moment, you can't spin the two freely from each other anymore. And so the whole system can still spin like this, but you can't spin the two atoms individually. And so once you have a double or triple bond, it stops the overall molecule from being able to freely rotate. Okay, so hopefully that's a little bit more clear than what we talked about in class.